Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're doing day 3 multi-unit conversions. One thing you're going to notice about all the problems, okay, is that the units can be squared or cubed, which means that there's more than one unit, or we have a unit in the numerator and the denominator, as we do with problems 3 and 4. Okay, so let's jump right into it. Okay, if you're into notes, okay. These are the notes that we took for this particular day. So if you want to screenshot it and take a look at it, this was our first practice problems for the day. And we got 4 of them that we're going to work on in the video today. So the first one, we're going to deal with converting 48 decimeters squared, which means there's 2 dimensions. It's length times width. So we're talking about area units when we're talking about a unit that's squared. And we're going to convert those 48 decimeters into millimeters squared. So let's get right into it and set up our train tracks. Okay, so here's our train track, and we're going to put in 48 decimeters squared. Now, to make this problem really simple, especially if you watch the previous video, video 2, on multi-step conversions, we are basically going to treat this the same way as if we didn't even see the squares there, and then we're going to talk about how we incorporate the squares into the problem. So really, this is just going from one prefix to the other prefix, just like we did in the previous video. So if I had decimeters, I would convert it to the base unit of a meter, and then a meter back into the other prefix of a millimeter. And the ratio here is going to be 10 to 1, and the ratio here is going to be 1,000 to 1, because we've memorized these over the last couple days from our notes on day 1. So now to make this different, because since they're squared, it's talking about multi-dimensions. It's both length and width that make up the area. These conversion factors are only in one direction, okay? So to make them go in 2 directions, both length and width, we're going to make sure all of the units are squared. And if we square the units, we also have to square the conversion factors. Okay, so that'd be these guys. The only part that we don't square is the given, because that's what's stated in the problem. We actually have 48 decimeters squared as area. Okay, so we're going to go into our calculator. We're going to hit 48, and we're going to divide it by 10 squared, and then we're going to multiply it by 1,000 squared. And if you have one of these graphing calculators, okay, there's actually a square button, okay, right here on the left-hand side. So I'm going to be using this button quite a bit. So I'm going to do 48, and then I'm going to divide by 10 squared, and then I'm going to multiply by 1,000 squared. And when I get that, I should get an answer of 480,000. Now, I do want to explain this, why we squared the conversion factors. And I kind of want to make that make sense. So I have another diagram here. If I had this right here, which is an area that's 1 foot by 1 foot, we would know if we took the length times the width, 1 foot times 1 foot, this would be 1 foot squared, okay? However, if I wanted the area in inches, I wouldn't just multiply this number by 12 by saying that there's 12 inches into a foot, because we're dealing with area, okay? And when you're dealing with area, there's 2 dimensions. You have a length and a width, okay? So there's 12 inches this way and 12 inches this way. So you don't see just 12 little squares here. You see 12 times 12, which is 144 squares in here. So if I was ever to convert, okay, 1 foot squared into inches squared, I would have to multiply by 12 2 times, or in other words, 12 squared. And that's why we're squaring those conversion factors. Okay, so remember, we square the conversion factors, but not the given. Okay, so let's see if you can jump in and do the first part of problem number 2. So I would probably pause the video here and see if you can kind of repeat what I did up here for the first part of this problem. And when you unpause it, I'll be here working on the problem, okay? So problem number 2, the given is 3.12 meters cubed. So now we're talking about volume, length, width, and height to give it 3 dimensions. So 3.12, and it's meters cubed. And we're going to convert that into centimeters cubed. Okay, so I'm going to go from meters to centimeters. Okay, but remember, this is cubed, so these things are going to get cubed. And when I put in the conversion factor between centimeters and meters, we know it's 100. But since the units are cubed, the conversion factor has to be cubed as well. And this is the work that we have to do. So I'm going to plug this into the calculator. Okay, I'm going to do 3.1. Let's try that again. 3.12. Okay. Now I'm going to times that by 100 cubed. So times 100. And there is no cubed button over here on the side. So I'm going to have to hit this caret, which means to the power, to power of 3 to make it cubed. And we'll get our answer of 3,120,000. Okay. So I'm going to put that answer right here, 3,120,000. Okay. And that puts me in centimeters cubed. Well, there's a second part to this problem, okay? And the second part of the problem is trying to get into the unit of liters. So all I'm going to do is continue this train track to get to liters. Now, there's an important conversion factor that was on our notes that I kind of want to point out a second time. And that important conversion factor tells me that there's 1 centimeter cubed is equal to 1 milliliter. Now, the thing that I want to point out is that for volume, it's always going to be some type of distance cubed, okay, or just some type of unit that has the liter. You will never see any of these units cubed, okay? So it's the distance cubed or some type of liter to the first power, okay? So what we're going to do is we're going to go from centimeters cubed to just the milliliter in this train track, and that's a 1-to-1 conversion, okay? So right now, the meters cubed cancel out, the centimeters cubes canceled out, and I'm left with milliliters, and we just got to go one more step from milliliters to liters, and that's going to be your normal conversion factors that you have that we've memorized, okay? That's 1,000 to 1 between the milli unit and the base unit. So 1,000 milliliters for every 1 liter. And if I do all of this math, the answer comes out to be 3,120 liters, okay? Because basically my last answer, times 1 divided by 1, but divided by 1,000. So I lose those 3 zeros, and it comes out to 3,120, okay? Now, the last 2 problems are a little different than the previous 2 because these have squares and cubes. There's no squares or cubes in problems 3 and 4, but there is a unit in the numerator and the denominator, and I want to teach you how to handle something like that. So let me work through problem 3 with you, and then I'd like to see if you guys can try number 4 all on your own. Okay, so the given is 3 for problem number 3. It's going to be 3.89, and it's decigrams per liter. So when I do my train track, the big thing that I want to do is I want to make sure that the numerator unit is in the numerator, but the denominator unit in the denominator. So it's going to look something like this. Decigrams as the numerator, but liters as the denominator. And as long as you set this up like this, the problem becomes pretty easy. Because all you do is you take care of one of these units at a time. So I'm going to take care of the numerator first, just like I did in the other problem. So decigrams here and grams here. And you'll see that the decigrams cancel out here. And now I have grams per liter. Okay, well, I don't want grams per liter. Okay, I want grams per milliliter. So now I'm just going to take care of the bottom unit. Okay, now here's the part that gets a little confusing. Okay, liters is on the bottom. If I want to cancel it out, where do I need to put it? Okay. Well, in the previous problem, decigrams was on the top, so I brought it on the bottom to cancel out. So if this is on the bottom, I need to put it on the top in order to cancel it out. And I want to convert over to milliliters because that's what the question's asking for. Okay, so if I cross everything out here, the decigrams cancel out, the liters are going to cancel out, and I'm going to be left with grams per milliliter. And that's how you solve the problem. Now, I still need to fill in conversion factors. There's 10 to 1, there's 10 decigrams per gram, and there's 1,000 milliliters for every 1 liter. So I want to let you know where I got that information from was the conversion factors that we memorized on the first day of class. Okay, so if we plug this into our calculator, here we go. We got 3.89 divided by 10 divided by 1,000. I get this answer of 3.89 times 10 to the negative 4. So if you see that E in there, that means times 10. So 3.89 times 10 to the negative 4 grams per milliliter would be the answer for question number 3. I want to see if you can do question 4 on your own. So pause the video here, work the problem out. When you unpause it, I'll be working on the problem. So question number 4 tells us 956 megagrams per deciliter. 956 megagrams per deciliter. So I got a unit in the numerator and a unit in the denominator. And all I'm going to do is take care of one unit at a time. So I'm going to do megagrams to grams first. So megagram to gram first. And then deciliter to milliliter. Deciliters on the bottom, so I got to bring it to the top. And the only thing I can change deciliters to is the base unit of liters. And then I'm going to change those liters to milliliters. And I got to plug in conversion factors. Grams to megagrams is 1 times 10 to the 6 grams for every 1 megagram. This is going to be a 10 to 1, and this is going to be 1,000 to 1. And once again, I got all of that information from the conversion factors that we have to memorize. Now we got to put this in our calculator to get our answer. So 956, okay, times 1 times 10 to the 6. So I'm going to do 1, hit the second button and the comma to get the E. So that's 1 times 10 to the 6 times 10 divided by 1,000. And if you look at the answer, okay, it looks to me like 9,560,000. 9,560,000 grams per milliliter. And this is how you handle multi-unit conversions.